Good afternoon, everyone. My name is Ahmad, and today I will be presenting our work on tracing information flows between ad exchanges using retargeted ads. We all know that when a user goes online and starts browsing the web, his information is being tracked by both first parties and third parties. For example, a user can visit a website like CNN, and in this particular case, the browsing activity is being known by the first party, which is CNN, and also by the third-party trackers present on CNN, such as Facebook and DoubleClick. The purpose of these third-party trackers is to collect information about the user so that they can show an ad to the user in future. Similarly, the user can visit other websites like Amazon and BBC, and in doing so, his browsing activity gets exposed to more and more third-party trackers. Well, so this shows that tracking is ubiquitous. However, this is not very surprising. You can actually visualize this in a browser using an extension like Lightbeam. But what you do not see are these red edges. These represent information sharing between ad exchanges, which implies that ad exchanges are not isolated islands of data anymore. They not only track your information and collect your information, they also share that information with other ad exchanges. We want to study these particular red edges between ad exchanges. And they happen in usually cookie matching. But let's first take a step back and try to understand what is happening in the ad ecosystem. So the modern ad ecosystem is moving more and more towards real-time bidding. Real-time bidding gives the flexibility to the advertisers to decide in real time whether or not they want to show an ad to the user. Each ad request is managed by an ad exchange which holds an auction, and advertisers bid during that auction and tries to win the bid and show an ad. But they rely on a key fact that they will be able to identify the user before bidding, because if they can identify, they can use the information they have about the user to bid high or low. And they identify the user using cookie matching and by sharing the information with the exchange, ad exchange. So this is a prerequisite in real-time bidding. And real-time bidding is getting more and more popular. An IDC report suggests that the spending in real-time bidding will cross $20 billion by 2017. And the spending will account for 80% of US display ad by 2022. Let's try to first understand what real-time bidding is. Let's consider this example. User visits a website like CNN, gets a response. Then the browser sends an ad request to an ad exchange like DoubleClick. Now at this particular point, DoubleClick asks its advertisers or ad partners whether they want to submit a bid on user or not to show the ad. And depending on the information they have about the user, these advertisers will submit the bid. And this process is basically real-time bidding. And somebody will eventually win the auction, and the it will be served a redirect so that it can serve the ad to the user. But there is a problem in this picture. How do these advertisers know or identify the user during this process? Because all they see is DoubleClick's cookie when the DoubleClick asks for the advertisers to submit bids. They cannot read their own cookie and identify the user. This is circumvented by cookie matching. So before real-time bidding, this must have had happened. Browser sends a request to DoubleClick. DoubleClick can read its own cookie, which is 1, 2, 3, 4, 5 in this case. And it sends a redirect to its ad partner, in this case, Christo, and it sets its cookie value in the URL parameter. So in the next request, the browser will send a request to Christo, and Christo can read its own cookie, A, B, C, D, E. And in the URL parameter, since DoubleClick ID is there, it gives Christo the opportunity to create a mapping between its cookie ID and DoubleClick's cookie ID for a particular user. So in future, when DoubleClick will say, oh, you know what, you want to submit a bid, Christo just have to look in the database and see if there is a mapping. So we want to identify this relationship between DoubleClick and Christo. And it looks straightforward from here. Why can't we just like look at the HTTP request and look at the particular identifiers being shared? And actually, prior work has done that. They have looked at the identifiers being passed around, and using that, they have identified cookie matching partners. But they rely on HTTP requests, which has certain limitations. For example, one of the challenges could be the matching can be happening on the server side. Let's consider this hypothetical scenario. The user goes online and Christo, the one ad network, observes the user from a particular IP address. Later, at some point, another ad network, Right Media, observes the user using from the same IP. And behind the scene, they both can sync up for that particular IP for that particular user. And in this process, no information is going through the browser, no matching is happening through the browser. So just the analysis of HTTP request will not be enough. So let's take a look where the information is flowing through the client side or the browser. Still, there can be some challenges. Consider this browser and the environment in which it is running. It makes a request to Amazon, gets some response. Then it makes a request to DoubleClick, gets a response, and at this point, DoubleClick adds a JavaScript in the page. The next request goes to Christo. And the HTTP request in this, the GET request is obfuscated in this particular case. So at this point, we have no way of knowing who initiated this request, whether it was Amazon or DoubleClick script, JavaScript. So DoubleClick and Christo, who are ad partners, they can have some mechanism to deobfuscate and create a mapping. And they can do the matching, but just the analysis of the HTTP request will not be enough. So the goal of our study is to develop a methodology to identify these information flows between ad exchanges, and we want our methodology to be mechanism agnostic, that it should work in the face of obfuscation, and we want to detect both client-side flows and server-side flows. But how do we detect these flows, given the challenges I just discussed? We rely on the key insight of using retargeted ads, which are very specific form of ads where a user is shown an ad from a product he has viewed previously. For example, a user goes online on Amazon and looks for a particular Cisco adapter. Later on, he visits some other website, and this particular ad from Amazon follows him about that particular Cisco adapter. So the key insight is that because retargeted ads are very specific, we can use them to conduct controlled experiments. We know that a user visited some product at some point, and later on he was shown an ad, so there must be some information sharing going on in between. Following are our contributions. We present a novel methodology for identifying information flows between ad exchanges using a set of controlled experiments leveraging retargeted ads. We demonstrate the impact of ad network obfuscation in practice. We show that 31% of cookie matching partners would have remained unidentified using the heuristics used in prior work. We develop a methodology to categorize all information flows using a set of regular expressions. And we use these rules to actually show that Google shares its tracking data between its services on the server side. And we use graph analysis to infer the roles of each actor in the ad ecosystem as well. But due to time constraint, I won't discuss the graph analysis. I suggest you to read the paper for that. So moving on to our data collection part. As I mentioned, we use retargeted ads in our experiments. So the key observation is that retargeted ads are served under very specific circumstances. For example, user goes on Amazon and browses a product. Christo observes the user on Amazon. Later on, the user visits BBC and he was shown an ad from Amazon. And the ad was served from Christo. But notice that the request did not directly came from browser. There was an exchange involved. So they must have had matched cookies, as I discussed earlier. So this implies a causal flow of information between the ad exchange, from the ad exchange to the advertiser. And we use that causal relation for our analysis. To give an overview of our data collection part, we use an instrumented version of Chromium to visit a specific persona. A persona is an interest profile, for example, running shoes. And for each persona, we visit 10 websites. Considering the same example, these websites could be Nike, Adidas, etc. And for each website, we pick 10 product URLs related to running shoes in this example to visit. So overall, each persona will visit 100 product URLs. And once we have visited those products, we visit a bunch of publishers in hope that we will collect retargeted ads. We store all the images we observe, inclusion chains, HTTP requests, and responses. And we repeat this 9 times. And also notice that this flow is only for one persona. We created 90 such interest profiles or personas, and those were running in parallel. So in total, we collected 570,000 images, and we applied standard ad detection techniques using EasyList, etc. And we filter out images which were shown to more than one persona, because according to the definition, retargeted ads should only be shown in the persona they were observed in. So this narrows down our list from 570,000 images to some 32,000 potentially retargeted ads. I say potentially because it doesn't mean that if the ad was shown in one persona, it doesn't mean that the ad was actually retargeted. It could have been a contextual ad or a behavioral ad. We need to make sure that it is indeed a retargeted ad. But because of the size of the ads, we could not go through manually, so we decided to crowdsource that part. For crowdsourcing, we use Amazon Mechanical Turk to label our 32,000 ads. We divide these ads into some 1,100 tasks, and each task consists of 30 ads. 27 unlabeled, 3 labeled by us, which act as ground truth. And for each ad, we get 2 verdicts from 2 separate workers. This is how one of our questions looks like. This is an image we observed for a specific persona, in this case, in the jewelry. So we show the worker the image, and we show the persona the image was observed, and we ask the worker, oh, does this image belong to this particular persona or this category? And in this case, it does. It is from jewelry. And the next question we ask, oh, does this image come from a particular website? Because we know the websites, 10 websites we visited for a persona, we can show the list of websites as well. And you can also notice that in this particular case, the ad is from Adiamor. The worker will select that. And this implies that this is a retargeted ad. So in our final data set, we have some 5,100 unique retargeted ads. But notice that we observe one retargeted ad multiple times. For example, an ad could be served on BBC and on CNN, the same ad, and it could be served by different ad networks like Criteo and Right Media. So we actually consider each occurrence of ads separately. We considered that as a whole chain through which the ad was served, and we consider all of these chains. So in total, we have like some 35,000 publisher-side chains. Next, we want to classify those chains, like how the ad was served and which information sharing mechanism was used. Let's take a look at one publisher chain. In this particular example, the user, now these are retargeted ads. We know that these chains are retargeted ads, or deliver retargeted ads. So in this case, the user visited BBC and he was served an ad from Amazon via Criteo. So because we are seeing an ad from Amazon, we must have visited Amazon in the past. So for every publisher side chain, there is an associated shopper side chain as well, which we visited in the past. But the question is, how does Criteo know to serve us an ad on BBC? Well, in this case, it is pretty trivial. Criteo observed us on Amazon, it knew about our interest, and it later showed us an ad on publisher side, where it directly got the request from the browser. So next question is, can we classify all such publisher side chains? But to understand, we first see what we mean by a chain. For example, the request goes to CNN, the next request goes to Rubicon, which redirects, sends a redirect to Criteo, and the ad is served eventually. In this case, Rubicon is an exchange. Criteo is the advertiser which served us the ad. But the chain can get a little more complicated as well. CNN then sends a request to DoubleClick, which sends a redirect to Rubicon, which sends a redirect to Criteo. Notice that this can get complicated further. But how can we classify these chains? How can we capture these chains? We do so using regex-like rules. For example, in this particular case, we can capture these chains using the following rule. Like advertiser should appear towards the end, which is Criteo, preceded by an ad exchange, Rubicon, and at the beginning there should be a publisher, CNN. And in between there can be multiple trackers, any number of trackers. So using our regex-like rules, we classify these publisher side chains in four major ways, four possible ways. One is direct matching, two is cookie matching, three is indirect matching, and latent matching. Indirect matching and latent matching are server-side matches. But I won't discuss indirect matching due to time constraint. Next, let's take a look at direct matching. So the user was served an ad on Criteo, and the shopper side chain is from Amazon to Criteo. So in this case, all we need to know is that advertiser that served us the retarget got a request directly from the browser, which means that it can identify us. And on the shopper side, it must have observed us on Amazon so that it knows about our interest. And there can be any number of trackers present in between. So this is pretty simple, but this can get a little complicated. For example, let's consider cookie matching. Now, if you notice that the shopper side is the same, Criteo observed us over there, but now there is an exchange involved in the publisher side. Now the advertiser is not directly getting the request from the browser. It is getting a request from the exchange, like RTB, real-time bidding. But it still must observe us on the shopper side to know our interest. But in between, something like this should happen. There must be an exchange of information from the ad exchange to the advertiser. So in this scenario, if the publisher side chain matches this rule, the right side rule, and the shopper side chain matches the left side rule, and there is a match with the rule in between, we classify this as cookie match. So far we have actually discussed client-side matches, and we claim that we can actually detect server-side matches as well. Let's take a look at one of these matches, which we call latent matches. So in this case, the publisher side is the same. You can see that there is an exchange involved, DoubleClick, and there is an advertiser to MDN. But the key thing to notice over here is that neither the exchange nor advertiser observed us on the shopper side, but they still served us the ad on publisher side. So how did they know about our interest? The advertiser on the publisher side must have received some information from some shopper side tracker, right? Otherwise, it has no way of identifying us and knowing our interest. And we do observe some latent matches in practice in our data set. So to explain this particular case, we see that DoubleClick or 2MDN, they did not observe us on the shopper side, but Google did. And since DoubleClick and 2MDN are owned by Google, Google can aggregate data on server side and create a mapping for user. So moving on the results for our classification. So this table shows how our chains were categorized in 4 types. I'm not showing indirect matches because I did not discuss them. So the takeaway is, first, as expected, most of the retargets were due to cookie matches. Second, we observed very small number of chains that could not be categorized, only 2%. This shows that our rules were exhaustive and also low false positive rate in our AMT labeling tasks. However, we did find surprisingly large amount of latent matches. I say surprisingly because latent matching requires more collaboration within ad exchanges, and it requires collaboration on the server side. So we thought, why the number is so high? Why is this happening? And if you remember the previous example I just discussed with Google and 2MD and DoubleClick, we thought, what if we categorize all these domains under the parent domain? For example, we can cluster Google, DoubleClick, Google syndication under Google. And once we did that, we observed that essentially all the latent matches disappeared. And most of them involved Google, which suggests that Google shares tracking data across its services on the server side. Moving on. The next question we wanted to answer was, who are these cookie matching partners in our data set? So this table shows the top cookie matching partners we found in our data set. And these particular columns show the number of chains they appeared in which they did cookie matching, and number of unique ads which were served via those chains. The interesting question what we wanted to answer was, can we actually identify these cookie matching pairs using the heuristics used in prior work? So we looked at 3 heuristics. One, exact share match, where we looked at exact cookie strings. And second, special URL parameters, where we looked at parameters such as cookie sync. Third, we considered DoubleClick as a separate case, where we looked at special URL parameters provided by DoubleClick. Because DoubleClick hashes its cookies and never sends out the raw text, and it has a special URL parameter to identify the cookie values, which is Google GID and Google NID. And we considered that as well. So this particular row shows that Criteo and Google syndication, this particular cookie matching pair could have been found using the heuristics used before. In this case, special URL parameters. This particular row shows that Google syndication and Steelhouse Media, this cookie matching pair would not have been found using the heuristics used before. And overall, we found 31% such cookie matching pairs which would have remained unidentified using the heuristics used in prior work. So in summary, we developed a novel methodology to detect information flows between ad exchanges using a set of controlled experiments leveraging retargeted ads. Our methodology works in phase of obfuscation, and it can detect both client-side flows and server-side flows. Our dataset gives a better picture of the ad ecosystem. It reveals which ad networks are sharing information about the user, and we can also reason about how information is being shared between those ad exchanges. And with that, I'm happy to take any questions.
Rabimbor, Rice University. So I was just wondering, did you also try to look at any tracking data that may be shared between apps and websites? For example, if you have Google, is my chatting data from Hangout is shared with something else? For Telegram, if I use the web Telegram version, is that data is being shared with somewhere else? So if I talk with somebody on a specific topic and I get relevant ad in Amazon about my buying choices, did you look into that?
So you're talking specifically about Google case, right? So no, we did not take a look at this, but according to Google, like a couple of years ago, they changed their policy. They can actually share data between their services. For example, they can look at, they can use the information you used on YouTube, and they can use later that somewhere else with their, and they can match that information with their other services to show you something. But we did not take a look at that.
I have a question for you.
Yes.
So you use a set of personas to come up with a set of rules, matching rules. I was wondering, did you use any like control personas? Essentially, I'm thinking that it could be the case that the persona was presented in an advertisement just by chance and not by causality. You have a causality statement essentially in what you're saying. And I'm wondering, how did you eliminate any confounding factors?
So if I understand the question correctly, you're asking how did we actually take care of false negatives, right? Okay, so that's a good question actually. Although we observed the ad in one persona, we had 90 similar personas running. Well, not similar, 90 personas running in parallel. And we were visiting the same set of publishers. So, and we had a control as well with each persona. So we try to mitigate that using that. For example, if the ad, because we are visiting similar publishers, and if it's not a retargeted campaign, the ad should be seen somewhere else as well, or maybe in the control as well. But still, you're right, it can happen. Worst case scenario, it was not a retargeted campaign. Yeah.
All right, let's thank the speaker again.